Thank you for joining us for this session, where I'd like to convince you that the use of our simulation and analysis tools will help you to build better web handling machines. My name is Paul Goossens, Vice President of Platform Strategy at Maplesoft. We're going to show you the web modeling capabilities with MapleSim. But first, allow me to pose a question to you. Here we see two sets of results, one from a simulation and the other from a machine test. My question is, what's the main difference between the two? Well, the difference is that the simulated results cost a few $1,000s in research and remodeling time, and the real results cost millions in building the machine, instrumenting it up, and running the tests required to acquire these results. And this, in essence, is what the real value of early-stage virtual prototyping provides. For a very modest investment, you can gain a tremendous amount of insight into the behavior of your machine before you start cutting metal and building your machine. This provides many business advantages in terms of reduced time and money spent on physical machine prototyping, reduced time and money on physical commissioning, using virtual commissioning to prevent product misalignment and machine failure, and safety testing situations that would damage the machine or harm the operator. The business argument for implementing early-stage virtual prototyping is extremely compelling, particularly if you're only hitting integration issues during the first machine build. There are plenty of studies to show, and I'm sure that you've experienced this directly, that if an issue that forces a design change request is not caught in the early stage phases, it can cost significantly more in the prototyping stage alone. This shoots up to orders of magnitude greater in the later stages. And this is a drop in the bucket if this comes to light after the machine is on site and forces a production shutdown. This is where Maplesoft can help. We're a leading provider of high-performance tools and technologies for solving a myriad of technical problems in engineering, science, and applied mathematics. Our software and services touches hundreds of thousands of people worldwide, and we're well known in our expertise in system-level modeling and mathematical analysis. In the context of this presentation, we provide tools and expertise to help our customers to implement rigorous simulation, analysis, and optimization techniques to design better machines by providing greater insight into the dynamic behavior of their machines. We do this by helping our customers to solve complex vibrational or control problems in existing machines, or to implement our tools early in the design phase to avoid them in future machines. Our expertise lies in 4 areas in the engineering design process: advanced analysis development with Maple, calculation management with MapleFlow, dynamic simulation and multi-domain systems with MapleSim, and model-based systems engineering with MapleMBSE. For this presentation, we'll be focusing on MapleSim with the web handling library. MapleSim offers many powerful capabilities for building and testing your machine design, allowing you to combine mechanical, electrical, hydraulic, pneumatic subsystems with the control systems into a complete system model to run dynamic tests and identify issues in the design very early in the process. It also allows you to use the insight you gain to improve machine performance through rapid trade studies or more formal optimization techniques. And finally, you can use the system model for real-time in-the-loop testing of your controllers before you integrate them with the real machine, thus reducing risk of damage. With MapleSim, you can start with the mechanisms in your machine to determine the kinematic and dynamic behaviors, and hence the inertial loads on your actuators. Then incorporate the right size actuators to drive the mechanisms. Then incorporate other design elements from your material properties and your customer requirements. And now you can incorporate the behaviors of your product in the machine with our new web handling library. This allows you to address many of the challenges facing manufacturers and operators of web handling machines. Specifically, we can focus on 4 main areas: web slippage on the controllers, web tension control in the path, curl in laminated webs, and mitigation of troughs and wrinkles in the product. MapleSim Web Handling Library allows you to model web handling machines that integrate the underlying physics of the web product and guiding mechanisms with the rest of the machine. There are blocks for entering web material properties, web spans, rollers of various types, web sources and sinks. For example, unwinding and rewinding rolls. There are also sensors like tension load cells and other elements needed to model assemblies like accumulators and rotary dancers. These components can be connected together to model web paths in converting machines. These components allow the unique dynamics inherent in web handling to be integrated into the machine model, such as roll-to-roll for paper, foil and compound materials, and web lines, including mechanical dancers, rollers, clutches, brakes, and actuators. Once the model is created, it can be used to analyze many different scenarios. For example, you can study the effect of roller slippage on the controllers and actuators. You can also test extreme scenarios and investigate how the machine will respond without risk to the machine or its operators. And you can use it to optimize the machine's performance, maximize output while minimizing wear and tear on the machine or the product. As a quick example, let's look at this model of a simple unwind dancer used to control web tension. In this mechanism, there is an unwind roll, several idlers, a spring-loaded dancer arm, and a driven roller. There is also feedback from the dancer arm position to the brake on the unwind spindle. This animation is one of the outputs of the simulation, but the real value from the model are the physical results from a test. Here's a plot of web tensions for each span over time. The tension differences are due to idler bearing drag and the driven roller speed versus web speed of the unwind spindle. Without getting into the specifics of these results, the critical thing to note is that to acquire these from a real machine would require very expensive instrumentation and a lot of wasted product. This is a direct illustration of my earlier point that a small investment in using tools like MapleSim can provide the behavioral insight you need to identify problems for a fraction of the cost of doing this with the real machine. This example is just one of many, presented by one of the leading experts in web handling machines, Steve Lang. You can find his workshop on web handling troubleshooting on our YouTube site. Here's a longer web line model showing the lamination of 3 films. It can be used to confirm roller layouts and span lengths before commissioning. In summary, early-stage virtual prototyping using tools like MapleSim with the web handling library not only helps you to build better machines, it'll save you a huge amount of time, money, and stress on your project. It allows you to troubleshoot your design early in the design process where costs are low, and not during your first customer build. Many thanks for your time and attention. We have more application examples and MapleSim product details on our website, maplesoft.com/webhandling.